Hi, welcome to the 8th grade volume lab. You will be able to conduct your experiment on your given day after you have watched this YouTube video and after you have turned in the review papers, that being mean, median, and mode, and range, significant figures, multiplication and division, significant figures addition and subtraction, and lastly the percent error worksheet. In this lab, we will be studying the volume of regular solids, irregular solids, and irregular solids that have a lower buoyancy than that of water. The lab starts off asking you to define density in your own words and write the equation here. There's two parts to that question. We just reviewed the purpose, and now we're going to review the materials that you're going to need for the lab. Your materials include a 1 centimeter cube, 1 glass marble, a sandstone rock, a styrofoam ball, a 100 ml graduated cylinder, a triple beam balance, one to 3 sinkers, string and a needle, a pair of scissors, your metric ruler, and a 25 ml graduated cylinder. Also, don't forget your measuring tray. You may have a different one that looks like this that you can use as a measuring tray. All right, you are ready to begin your experiment. Remember, use the time in the lab to take the measurements of the object's mass and the volume. All the other calculations can be finished at home. This lab is designed for you to complete it within your allotted time frame. Okay, let's look at page 2, where we are going to determine the mass of each of our samples with the triple beam balance. When you have your triple beam balance, make sure that all of these riders are on the 0 mark. Just as a reminder, you start moving the middle rider first. That is in increments of 100 grams. Then you move the middle rider second, which gives you increments of 10 grams. Lastly, you move the smaller rider, which is increments in 1/10 of a gram. So before you get started, you want to make sure that they are all to the left side on the 0 marking, and that your 0 marker points to 0 here. When you are ready, get your weighing pan. You can put that on your triple beam balance. Remember to find that mass before you add any objects to the pan. You want to subtract the total mass minus the mass of the pan to get the mass of each of your objects. You're going to find the mass of the small cube, the glass marble, the rock sandstone, and the styrofoam ball. Next, in point 2 of page 2, you're going to find the volume of each of your samples. The bullet points below help remind you how to find the volume of a regular solid, an irregular solid, and an irregular solid that has a lower buoyancy than water. So you may want to use your metric ruler for a regular solid. Water displacement in one of these two beakers for an irregular solid. And then for a volume of an irregular solid that has a lower buoyancy than water, use your strings, your needle, and your weights for your styrofoam ball. After you tie your string around your weights and you thread your needle, stick it in the styrofoam ball and find the water displacement in your graduated cylinder. That would help you find volume. Remember, you're going to have to find the mass of the weights, the string, and the needle, and the volume of this separately from the styrofoam ball in order to get the actual density. Point 3 on page 2 says then to calculate the density in grams per centimeters cubed. After you complete sections 1 and 2, you can calculate your density of your cube, glass marble, your sandstone rock, and styrofoam ball. The last parts of the experiment on page 4 and 5 asks you to find the percent error. Given the known density for glass and sandstone, you can plug in what your measurements were for glass and sandstone and find the percent error in the density. The last part asks you to think about some questions regarding density, mass, weight, and volume.